Hi, this is Mrs. Sigmund. I'm going to go through the lesson on writing expressions, simplifying expressions, and evaluating expressions. So if you're taking notes in a notebook, this is part of Unit 1, and then I would write down a date that you are viewing this video. So if this is Monday for you, then this is August 31st. Okay, so to start, we're going to translate between verbal expressions and expressions that have numbers, variables, and addition, subtraction, multiplication, and division signs. So you may see some of these words in a word problem or just written expression that we need to convert into a math expression. And so we want to organize these into what would make sense for which operation they're talking about. So you can see in this table, words that we use for addition would be things like more than, increased by, sum, or plus. Subtraction, you're going to see things like the difference, fewer than, less than, minus, and decreased by. Multiplication, we'll see words such as times, of, product, multiplied by, and quantity. And then for division, we use divided by, we call them a quotient, or the term per. So when we go to translate, again, we may have sort of a verbal expression like what you see here. Then we're looking for a mathematical phrase. So 8 times the quantity, 7 minus a number, tells me a few different things. Because I have times the quantity, I know I want to do multiplication. I'm going to have an 8 on the outside, and then this quantity is going to be whatever follows. So I have 7 minus a number. So here you see my 8 times the quantity, and then inside I have 7 minus a number. If we don't specify which letter, you can just pick any letter. I would be careful with using things like an S or a Z or an I or an O or a lowercase t. Those sometimes look like numbers. So just be careful with those unless you write them a certain way that would kind of specify whether you're looking at a number or a letter. 10 divided by the sum of a number and 2. Because of this piece, the sum, I know that everything that follows right here is going to be part of an addition problem. So my number and 2, because of the order that's given, I'm going to have a letter plus 2 because of sum. And 10 divided by that sum means that that whole sum is in the denominator. So I have 10 divided by the sum. You may want to use parentheses when you see the sum or the difference. And then I have a number and 2. 9 times the quotient of 5 and a number. Well, quotient tells me that we're dividing. So I have 9 times the quotient of 5 and a number. And again, the order that it was presented to us in the original problem tells us where the m and the 5 line up. Lastly, we have 3 more than the difference of 1 and a number. Again, because I have the difference, I want that in parentheses. So I'm going to have my 1 and a number, and then I'm going to add 3 at the end because of the word than. So we have 3 more than something that's going to come at the end. So here's my difference of 1 and a number, and then my plus 3 at the end. This is just the opposite. So maybe we have a numeric phrase and we want that written out in words. So if you see something like this, you have a variety of options here. So I have 2 times the quantity of y plus 11. You could also say 2 times the sum of y and 11. There's going to be multiple answers that work for the same problem. Here, we want to indicate that we have this 3 as an exponent. So maybe we say n to the third power increased by 5. You could also say plus 5 or 5 more than n to the third power. All of those are fine. Here we have 18 plus the product, that tells me multiplication, of 3 and d. It helps me group those two things together to be 3d in our expression. And then we have the difference of 55 and the product of 6 and k. That gives me everything that's on the top. divided by 2. It helps so that we aren't dividing in the wrong place. We want that 55 and the 6K all in the numerator. Moving forward into simplifying expressions, we want to talk about combining like terms. And when we talk about like terms, they have to have the same variable and exponent combinations. So if you look down here at the example, my 3x and 5x are like terms. They both have x to what looks like no power, but really there's a 1 there. But 3x and 5x squared are not. They both have x's, but this is to the second power, this one is to the first. So they are not like terms. When you combine like terms, we're going to use the variables and exponents to help us identify which pieces are like terms. So here you can see this problem, I've separated them out with colors. So I have 12xy and the negative 4xy are like terms because they have the same variables and exponents. Same with our 5x and 2x. But when we combine them, we only combine the pieces in the front, the numbers that in the front called coefficients. So I'm going to do 12 and negative 4 combined, and then I'll also do a 5 plus 2. And so that gives me 8xy plus 7x minus 9. That's simplified because I no longer have any more like terms. Okay, then we jump to our order of operations. As you simplify these expressions, we want to follow the order of operations. It makes this so that we all get the same answer and we solve in the same order. So you may recognize PEMDAS, and those stand for parentheses. Simplify any operations that need to be done in parentheses. Then we will jump to exponents, take care of those. Then we do multiplication and division. And this just comes as we work from left to right, like you're reading a book. However, they show up in our equation or expression. And then we'll look at addition and subtraction. And you can work from left to right, but it does not need to work that way for addition and subtraction, as long as you keep the sign that's in front of the term, just like when you combine like terms. So sometimes people use please excuse my dear Aunt Sally. Again, you can see that PEMDAS, or you could come up with your own phrase that follows the same pattern. Okay, so here's an example for order of operations. As we go through this, we want to look for each of those letters. So our first letter is P. We're looking for anything that needs to be done inside parentheses. And I see I have that 8 divided by 4. So we're going to take care of that first. That gave me 2 in parentheses, and I left everything else the same. I still see parentheses, but there's nothing for me to do inside, so then I'm going to jump to exponents. 2 to the third is just 2 times 2 times 2, so that gives me 8. And again, everything was left the same. So then we're jumping to multiplication and division. We have a 12 divided by 4, so that gives me 3. And then we just add 8 plus 3 to get 11. Okay, there's a lot of steps that you can take here to get started. We have 2 sets of parentheses, so you can go ahead and simplify them at the same time. You can do 7 plus 2 to get the 9, and then 16 minus 13 to get 3. Then we're going to do this exponent piece. Only the 3 has the exponent, so that's going to become a 9. Everything else stayed the same. When we move into multiplication, we actually have 2 pieces here that don't overlap, so you could do them at the same time. 9 times 9 gave us this 81, and then the 4 times 6 gave us 24, and I left that negative 15 in the middle. Then you can just work from left to right for addition and subtraction. If you do 81 minus 15, you get a 66, maybe as a middle step, and then combining with that 24, we get a 90. To evaluate, you're just going to substitute a value into the equation. So this one says that we want to use x equals to 5. So we'll just plug that in. So here you can see that same expression just with a 5, replacing each x, and then we'll follow order of operations to simplify. So we'll do 5 squared to get 25. And then it's just addition and subtraction. So we have 30 minus 12 to leave us with 18. This one's a little bit more complex. We have two things that we're plugging in, a 3 for all of the x's and a -4 for all of the y's. So you can see those here just plugged in blue. Everything else stayed the same. And then I'm going to go ahead and do all of this multiplication. So 10 times 3 gave us 30. -2 times -4 became a +8. With this third term, I did my 3 squared before I can multiply by the 5. So that's why we still see 5 times 9. And then 7 times -4 gave us a -28. So we still need to take care of one more piece of multiplication. That's that 5 times 9 to get 45. And then we're just adding and subtracting to combine those last 4 terms to get 55. When you distribute, we're just talking about multiplying a number usually in front of a set of parentheses. So we're going to take this number and it's going to get multiplied by each of the terms in parentheses. And so 2 times x will give us 2x, and 2 times 3 will be 6. Okay, so we'll go through some examples. Again, we want to take that 27 and multiply by both terms in parentheses. 27 times 2b, we do 27 times 2 to get the 54 and then keep the b. And then 27 times 1/3 is just like 27 divided by 3. So we get 54b plus 9. In the second example, we're distributing a -a. So again, it's going to multiply by each of those. We're left with a -ab plus 6a. This one looks a little bit backwards because the 2 is happening after the parentheses, but it just distributes the other direction. It's still going to go to each term inside. We have 2a minus 6b plus 4c. And again, we're multiplying by each term. Okay, so that finishes up expressions. There's an assignment in Reveal, and there's also a PDF version in Schoology. So you can either print that off and do the work by hand and then just submit a picture of your work, or you can download it in Kami to show your work, or you can just do the assignment in Reveal if you have access to that. And then that's an assignment that you can do in your asynchronous time.